yesterday we get electric field intensity and small charge particles Q1 quantitative charge and rings theory as particles charge electric flow on a rings. Then T is equals to K, we get T is equals to K Q and 2 pi r square. Then or capital R square. And electric field intensity, we know that E is equals to KQ divided by R square. Then solved in numericals, two particles each having a mass of 5 gram and charge 10 to the power minus 7 coulomb stay in limiting equilibrium one horizontal table with a separation of 10 centimeter. Between them find the coefficient. Between them find the coefficient. A separation of 10 centimeter between them. Find the coefficient of friction between each particle and the table which is the same between each particle and table. Then solution. You see, with a separation of 10 centimeter between them, then find the coefficient. Find the coefficient of friction between each particle and the table which is the same between each particle, and that's its table. We know friction force F will balance. Friction force F will balance the electrostatic repulsion. The electrostatic repulsion. Then we get F is equals to mu mg is equals to q square divided by 4 pi epsilon 0 into r square. And this F opposite side of this and this opposite side of this, and mu into 5 by 1000 into 100, that's 10 to the minus 7 whole square, and 10 centimeter between them, the separation of 10 centimeter, and 9 into 10 to the power 9 into 10 to the power minus 7 square divided by 0.10 square equals to mu equals to 0.18 is the answer of this numerical for mainly JEE Main, Kvpy and JEE Advanced. Then second numerical, a particle of mass m, carrying a charge minus q1 and towards the moving around a fixed charge plus q2 along a circular path of radius we get r. Prove that period of revolution. Prove that period of revolution t of charge minus q1 is given by t is equals to 16 pi cube epsilon 0 root of 16 pi cube epsilon 0 mr cube divided by q1 q2. And we know q2 is a circular path. That's it. M mass minus q1 is the charge, negative charge, and v. Electrostatics force on minus q1 due to plus q2 will provide the necessary centripetal force. Hence, k q1 q2 by r square is equals to mv square by r is equals to v is equals to k q1 q2 by mr, and t is equals to 2 pi r by v is equals to 16 pi cube epsilon 0 mr cube divided by q1 q2 root of. Proof that. Yesterday we know that electric field intensity is represent to strength of effect of charge at a fixed point. Then we get E is equals to K of Q divided by R square. Electric field intensity is equals to K Q divided by R square. That's it, electric field intensity. And unit of E. Unit of E is equals to Newton per Coulomb. That means dimensional formula of E is equals to force by charge. That means force ml t to the power minus 2 and charge equals to ampere into time. That means m l t to the power minus 2 divided by a into t. That means m l t to the power minus 3 a to the power minus 1. That's the dimensional unit of electric field intensity E. And electric field due to a point charge. Next, positive point charge plus q of r radius p point and E electric field intensity. E is equals to 1 by 4 pi epsilon 0 into q by r square away from the charge. And next, negative point charge is equals to minus q r radius E, that's direction, and p point. E is equals to 1 by 4 pi epsilon 0 into q by r square towards from the charge. opposite direction of E towards from the charge and the same directions of electric field intensity away from the charge. Next the direction of F vector will be the same as that of E vector. It Q is positive and opposite of Q is negative. Then E vector is equals to F vector by Q is equals to F vector is equals to Q into E vector. With the direction of F will be the same as that of E vector if Q is positive and opposite of Q is negative. Then E is equals to E vector is equals to F vector by Q is equals to F vector is equals to Q into E vector. That's it. The direction of same away and the direction is same, F0 vector and Q quantitative charge, and that's it. The opposite direction of F vector and minus quantitative charge, and that's it. Then we get another definition can given as E is equals to limit, and when electric field is measured of due to a point charge Q, the test charge taken very small. Another definition can be given as if E is equals to E means electric field intensity and limit Q0 to 0 and F vector divided by Q0. That means quantitative charge. And E electric field intensity when due to a point charge Q and the test charge taken very small and electric field measured when this equation is applied, then Q has no contribution. Base notes for Kvpy. Q has no contribution in E, electric field intensity. A particle charge is not affected due to its own field. It means a charged particle can experience force due to a field produced by other charge, and particles but not due to field produced by at P due to charge Q is equals to electric field intensity is equals to Q into R vector minus R0 vector and 4 pi epsilon 0 into R vector minus R0 vector cube. Then repeat of itself. Before we get F is equals to QE, F vector is equals to Q into E vector. That means this is the force on Q, this is the force in Q by E. This is the force on Q by E vector. Base notes for Kvpy. Q repeat of Q has no contribution in E. A particle of charge is not affected due to its own field, and it means a charged particle can experience force due to field produced by other charge particles but not due to field produced by at P due to charge Q is equals to Q into R vector minus R0 divided by 4 pi epsilon 0. That means this, and this is defines R vector minus R0 vector divide whole cube. And note that, and if you have any fault, comment the below sections in this channel and contact us